Hi, welcome to a video series on visualization of analog communication concepts using LabVIEW. So in the first video, we'll see the standard amplitude modulation. This is the expression for message signal and carrier signal, which will be used for generation of standard AM signal. So SFT happens to be the amplitude modulated signal, which is given by the expression which is AC into 1 plus Km of t into cos 2 pi FCT. So where K is the amplitude sensitivity factor, and we have this as the expanded expression for SFT, which has one carrier signal and of course the multiplication of two cos signals, which will result in two sidebands. And as we know, K into M of t happens to be the modulation index of the amplitude modulated signal. So as we discussed in the earlier slide, so this is the message signal and these are the two sidebands, so which are occupying the frequency Fc minus Fm and Fc plus Fm. So by taking the Fourier transform of this modulated signal, so we're going to have delta functions at Fc and Fc plus Fm and Fc minus Fm. So this is what we are looking for when you are doing a standard AM modulation. Because it's a single tone signal, we're going to have three delta functions, one at the carrier frequency and two more at two sideband frequencies. So this is again the same SFT signal, which is realized using one adder, and there is a multiplier which is supposed to multiply Ka into message signal, and the addition of these two is again multiplied with this. So that's what is realized here. If you can see here, so one addition term which is representation of this, that is having 1 plus and the multiplication of Ka into the message signal. This is that Ka into message signal, this is multiplied here, and this addition of message plus the constant term is again multiplied with carrier signal, which is over here being represented using this multiply block. This is the spectrum what we are looking at. So if you can see, there are delta functions at positive frequencies, one at Fc with a magnitude of AC by 2, and you have one upper sideband Fc plus Fm and Fc minus Fm. So they have the corresponding magnitudes as shown here. So we'll now go to LabVIEW simulation, try to understand how do we realize the same thing using the block diagrams. We are using LabVIEW 2015 version for realization of this standard AM. So let me just try to put that standard AM signal block diagram. So now this is the block diagram I'm supposed to realize. So let me have one multiplier. So I'll have a multiplier in the numeric Vi. So this is multiply. So, and I want to have one more multiply. Again go to numeric, then take one more multiplier. Let me place it here. So we need to have one adder also. So let me have an adder. Again go to numeric, and see here there is an adder block. So it is now placed. Now I need to realize this M of t, which is one of the input for this realization. I can go to this express. See, there is an input. In this input, simulate signal. So this will actually give you one such signal. So I have two signals, one for message, one for the carrier. So let me take this will ask you to specify what is the shape of the waveform or the frequency and all those things. So let it be by default value so and so. Let me just say OK. Since I want to have one more, so let me again take one more signal, go to express, input, and then signal generate. That is simulate signal. So let us consider this as two signals. You can see now. So let me again say it as default values. So let us go back to this, and then can you see here now we have almost got all the requirements. So this is M of t, which is over here. This is C of t, which is realized here. And you have two multipliers, one adder block, and of course we need to have a constant term 1, and of course we need to have a variable term Ka. So those are the two terms, and then we need to do this realization of these interconnections. So let us complete that. So let me do this Control T. Now I have this front panel also where I can visualize all these things. Now in order to edit the parameters of this simulated signal, so let me do select that and then do Control H. Control H will give me the Control H is nothing but help, so which will help the user to understand, okay, what are the parameters a user has to specify. So for this standard AM signal, so let us only specify the frequency and amplitude. So let us work with the default values of offset and phase. So now we are supposed to specify the frequency and amplitude for both message as well as the carrier signal. So let me just specify that. So you can see now this is the frequency. So for every parameter you can create a control. Now let me create a control so that I can externally vary it. So since it's a frequency parameter, if you can see that there's a frequency, by default it is 10.1. So I can change it now. With the frequency, we named it as modulating signal, let me say it as FM. And then I have the amplitude, one more create, again control. So now I'll call it as AM, the message signal amplitude. Similarly, I'll go to this and then create a control which is for FC, and let me take the amplitude. Let me create a control for this also, which is my AC, that is amplitude of the carrier signal. So now let us go to this and then try to specify this samples per second. So since we want to work with the highest frequency, something like 10 kilohertz or 100 kilohertz, let us keep this as around 1 lakh. So I have, this is now by default 1000. Let me keep it as, now it is 10,000, 1 lakh. Okay, this is 1 lakh. Even if you keep more, no problem. So let me keep it as 1 lakh. This is fine now. So of course I can adjust the frequency here. So let me do the same thing for this also. The number of samples for all the blocks has to be same, otherwise it will show an error. Okay, now this is also made 1 lakh. Now it's done. So let us do the interconnection of this. So for interconnection, if you can see, this is the block diagram what we are supposed to realize. So this is what we are supposed to realize. Let us connect this. So what I'll do is I'll do the connection. So this is one of the input for the multiplier. The other input for the multiplier is, let me do it. So let me start from here. Done. So for this, let me create a control which is KA, because this is an external control what you are supposed to realize here, and this is one of the input for your adder. The other input for the adder is a constant term 1. Let me create a constant whose value by default it is 0, but I need to get it as 1. So let me say it as 1 now. So this is also done. So this is now this will be multiplied with the carrier signal. This is 1. The carrier signal is coming down here. Now this is also. Now here we want to have the amplitude modulated signal. So let me create a graph indicator. So since this graph indicator is the time response of the SAM, that is standard AM signal, so let me name it as SAM. So let me try to see how does the, now if you can see here, since I didn't edit the values of FMFC, they are by default so and so. So let me just change this to 100. Let me change this to 1000. This is carrier frequency, modulating frequency. this is Ka, which is the parameter corresponding to amplitude sensitivity. You put it as 0.5. Now actually modulation index is Ka into AM. So now the modulation index is around 0.5. So if I run it now, let us see what we're going to get it. Amplitude modulated waveform. So since it is not properly visible, so let us change this x-axis, which is auto scale, to a user defined scale. Since it is 100 now, so this is in terms of 0.1 second. So let me just make it as I can edit this as 0.0. So let me see only 2 cycles. So this is 0.0. I can say I'm seeing only 2 cycles. If you want to see more cycles, you can change this to 0.04. You are seeing 4 cycles. Now if I change this modulation index, you can see if I make this as 1, so my mu modulation index will become 1. So now you can see it is 100% modulation. Giving the carrier frequency to a higher frequency, now kilohertz. Now you can see this is your carrier signal is increased. I can change this to a different frequency. Let me make it 200 hertz. You can see this is 200 hertz. Okay, this is how you can, now whatever change that I make over here is represented here. If you want to have modulation index of around 0.5, now this should be 0.5. So Ka into AM is modulation index. Now you can see it is 50% modulation index. If you want to have still lesser modulation index, make it as 0.1. It is 10% modulation index. If you want to change the frequency of the carrier, make it again 1K. Now you can see it is not properly visible. Usually the frequency will be pretty low. Let us make it as maybe now it is 10 kilohertz. Let us make it as 50 kilohertz and then just see what is the changes. Now, okay, let me make it 10K and let me make this as 0.5. Done. Let me now make this 0.5. This is so because your modulation index. Okay, let me just come down here and then make it slightly. So we kept that sample rate just 1 lakh. Let me make it, put one more 0. Let me change the same samples per second also as 10 lakh. So because that not properly making that samples per second in the carrier, we are getting this type of waveform. So let me just make sure that this is also properly done. So now you can see, let me make this also more 0. We are there now. Now let me again run. Now you can see it. Whenever you change the carrier frequency should be such that it should be always less than the sample half of hour. Make sure that the sample rate, whatever you are fixing here, is very high, so that even if you go for higher frequency, be satisfying that Nyquist rate of sampling rate should be always twice that of the signal frequency. Now actually we are supposed to see the, just turn this off again. Go to this express. In this you can see there is a output analysis, and then I want to see the spectral. So now you can see the spectral is coming. So now this is the spectral where you can see the delta functions at different frequencies, that is Fc and one upper and lower segments. So we shall see this changes to peak amplitude. Make this as linear and then say OK. Let us connect this. Here we have placed that spectrum measurement. So input is given from the standard AM signal, and we are seeing the waveform graph. Here this is the spectral what we are looking for. So one is, okay, here you can see the carrier frequency is at 10 kilohertz, the MOSFET signal is at 1 kilohertz. we have three delta pins, one at 10 kilohertz and one is at 9 kilohertz, other is at